Welcome back to a new machine learning tutorial. In this video we are going to talk about k-nearest neighbors regression. We are going to talk about the theory of the algorithm. We are going to code it using Python. We are going to talk about its parameters, and we are going to talk about how we can do hyperparameter tuning. Let's start coding.
Okay, so I'm going to be using Visual Studio Code in this tutorial, but you can use any code editor that you want. It's up to you. And I'm going to go with a Jupyter notebook like KNN, Regressor. Next, we can say like IPMB for creating a Jupyter notebook. I'm going to select my kernel quickly in here, and I'm going to type my algorithm name like KNN, Regressor, and let's talk about it. So the k-nearest neighbors regressor is a non-parametric machine learning algorithm used for regression tasks. It predicts the value of a data point by averaging the values of the k closest data point, which we can also refer as neighbors in the training set, based on distance metric. It's generally Euclidean distance, but you can use others too. The value of k and the distance function are critical factors that influence the model's performance. So we are going to be talking about how we can change them and how we can optimize the k-nearest neighbors regressor in this tutorial too. So this algorithm works by firstly finding the closest k points, and actually we can say like k closest points. It's going to be better like this, and what this means is the algorithm finds the k closest points to a new data point using a distance metric. It's generally Euclidean distance for numerical data, and I'm going to show you the formula of the Euclidean distance in a second. And in the second step, it does the averaging the target values of these k neighbors to predict the target value for the new point. Okay, there was an issue with my keyboard language, so I'm going to retype this. So averaging the target values. Okay, so let's talk about the Euclidean distance between 2 points, x1 and y1 in the coordinate system and x2, y2. For finding the Euclidean distance between these two values in a two-dimensional space, the formula is going to be distance is going to be square root of the x2 minus x1 power of 2 plus y2 minus y1 power of 2. So this is going to be our Euclidean distance formula, and in higher dimensions the same formula applies but extended for each feature dimension. Okay, we can start coding right now. What I'm going to do is I'm going to firstly create my data. So for that I will say from scikit-learn.datasets import make regression. Next up I'm going to say x, y. I'm going to create something like make regression. Number of samples is going to be 200. Number of features, let's say 5. Next up, I'm going to add a noise like 20. And I think it's enough. So here is the x matrix we have and the y vector like this. So this is the y vector we have. And also we can check its shape. Like, give me a second. It's the x matrix. I will say shape like this. And there's a typo, it's going to be shape like this, and here is our y vector, and here is the shape of this. Okay, so we are going to work with this data right now, and as we can see from the y, we have a regression problem in here. Okay, so we are going to build the base model right now before the hyperparameter tuning. So for that I will say from scikit-learn.model selection import train test split. From scikit-learn.neighbors import k-neighbors regressor like this, and I will say from scikit-learn.matrix import mean squared error. So we are going to be using the mean squared error for evaluating our model, train test split for splitting our data, and k-neighbors regressor is our topic in this video. By the way, I have tutorials on mean squared error, train test split, and concepts like that. In my machine learning tutorials playlist, I have more than 40 videos just like this one. You can check that playlist for learning about more on these topics. So I will say on the train test split side, xtrain, xtest, ytrain, and ytest. And I will use train test split with giving x and y, and I'm going to set the test size as 0.2, which means that 20% of the data I have is going to be in the testing set. And I'm going to initialize the base model like KNN is going to be k-neighbors regressor Next, I'm going to train my model. Like, by the way, I don't want to see any type of warnings. I'm not sure if you are going to get any depreciation warnings, but I'm going to filter out them quickly, like this. Next up, I'm going to say knn.fit xtrain and ytrain. So I have my model trained right now, and we can do predictions with that right now. I will say knn predict. I'm going to call this on x-test. So we are going to have a prediction array like this. Now it's time for comparing this with the y-test, which is the true y values we have. I'm going to set this to something like y predictions. Next up, I'm going to call the mean squared error with y-test and y predictions. By the way, we want this mean squared value to be lower on regression problems. Now we are going to do hyperparameter tuning, and we will try to get low values from this. Like, we are going to try to lower this. Okay, let's talk about the parameters of the model. I'm going to go one by one. I'm going to explain them. Then we are going to code it. We are going to talk about 3 parameters. We are firstly going to talk about number of neighbors. This is the number of neighbors. It's simple, which we can also refer as k. We have the weights, and it's the how to weight the neighbors' contributions. Like, it can be uniform or distance based. And we have the p. This is the power parameter for the Minkowski distance metric. 1 means Manhattan distance, 2 means Euclidean distance, that talk about its formula at the start. Okay, so these are our parameters, and now we are going to code for optimization using grid search. So we will say from scikit-learn model selection import grid search cross-validation. Next, we are going to define the hyperparameters and their ranges. Like, parameter grid is going to be number of neighbors. Firstly, let's go with the same order. I'm going to say 3, 5, 7, 9, 11. You can extend this list, it's completely up to you. I'm not going to enter too much values. I'm going to say weights, and it's going to be uniform or distance. And next up, I'm going to say p, and it's going to be 1 and 2, like this. Now I'm going to set the grid search. Like, grid search is going to be, I'm going to initialize the grid search cross-validation. I will give k neighbors regressor. Next up, I'm going to give my parameter grid. Next, I'm going to set the cross-validation as 5, which means we are going to have 5 folds. And I'm going to set the scoring like negative mean squared error. So we have our grid search set up. Now I will say grid search.fit xtrain and ytrain. So after this, we have our estimator, and we can reach to the best parameters selected by calling grid search best parameters. So 5 for the number of neighbors, p2 for the power parameter, so it picked Euclidean distance, and weights picked as distance. So now we can make estimations with this model for comparing it with the base model we have. So I will say grid search best estimator dot predict, and I'm going to pass the x-test in here. Now I'm going to save it to something like y prediction tuned, and I'm going to call mean squared error on y prediction, y test, and y prediction tuned in here, like this. And here is our mean squared 23. So let's compare it with the previous value on the base model. So it was around 1000, and now it's 23. So we lowered the mean squared error a lot, which means we improved the model performance using grid search. Great. And if you want to export this model, you can just say import joblib, and then you can say joblib.dump, and you can give like grid search best estimator, and you can say knn regressor.pickle. So when you do this, you are going to see the file in here. So you are going to have your model exported, and you can load it back using joblib. Like model, you can use joblib.load, and you can just pass the file name in here for using the model for making predictions or taking the feature importances. Great. Let's summarize what we did in this video, and then we can finish this tutorial. So firstly, we talked about the knn the logic behind the algorithm, and we talked about the Euclidean distance formula. Next up, we create the dataset in here, and I showed you the X matrix with the Y vector. Next up, we apply data splitting, train and test splitting in here with the test size of 0.2, which means that 20% of the data is going to be in the testing set, and in here we initialize the base model KNN. Next, we train the base model, we make predictions with the base model and compare the predictions with the true Y values, and we get the mean squared error value of 1142. Next up, we talked about the parameters that the model can take, and I showed you how we can do parameter tuning using grid search for model optimization, and we found the best parameters in here. Next up, we make predictions with the tuned model, and our mean squared error lowered to 23 in here. And at the final, I showed you how you can export this model and use it in your apps using joblib.log. Thanks for watching. Let's get to the outro.
Thanks for watching this tutorial on K-nearest neighbors regressor. I have a machine learning tutorials playlist where I have more than 20 videos just like this one. You can reach that playlist from the cards of this video or from the link in the description. Also, I'm sharing a new data science video every week on my channel. You can subscribe to my channel for more videos like this. Have a great day.